Hey everyone, in this video we're going to be doing a continuation of sort of our last video where we did linear approximations, except we're going to answer an important question that you will most likely see on the AP test in relation to these linear approximations. Remember, with the linear approximation we sought to draw a tangent line. So if we had a function, right, and we knew the value at some point here, but we wanted to know it may be out here, what we did is we drew a tangent line. We found the equation of a tangent line, and then found the value on that tangent line, and said that was close enough, or pretty close to the actual value on the function. So we use that as an approximation. So we're going to be doing that, except in this particular video, we're going to be trying to determine if these approximations are overestimate or an underestimate. So that's the overarching question here: is this an overestimate or underestimate? That's what we're going to seek to answer. Overestimate or underestimate. So this first example that I little sketched here, in this particular case, you could probably determine that this would be an overestimate, right? Because the point that we're using to estimate here is above that point. So this would be an overestimate, right? Now, let's say if I wanted to do the same thing, except I were making my approximation somewhere down here. So maybe this is the point we know, and we're trying to estimate this point here, right? So I draw my tangent line, and I use the point right here to estimate that one. So since this one is below it, this is going to be an underestimate. So the way that we can determine whether something is an overestimate is by looking at the concavity of the function. So up here, the overestimate, you could see it was concave down, right? And on the underestimate was concave up. So you might make a note of that, maybe write that in your notes there. It's an overestimate if it's concave down, because that means the tangent line is then on top of the function. Okay, and it's an underestimate if it's concave up, because that means the tangent line then is under the point we're trying to estimate. It's under the curve. So hopefully that makes sense. Again, concave down, our tangent line is above the curve, and a concave up, the tangent line is below the curve. So we're going to be looking, we're going to be writing our tangent line equation, again, still making our approximation. But then after that, we're going to be looking at the second derivative and determining the concavity to determine if this is an under approximation or an over approximation. So let's go ahead and get started. We're given just a little bit different information on this one, but just like we did on the last section where we write our tangent line equation, we basically need an x, we need a y, and we need an m in order to do this. I'm going to use the formula that I've seen in most places for finding the equation of the tangent line. That's the point slope one, which, remember, if we have the y minus y1 equals m times x minus x1, we just sort of rearrange this, add the y1 over, and the y becomes the y1 plus m times x minus x1. I'm going to use this derivation of the formula just on all of them, just so we're not doing extra work on this one. But feel free, if you want to use the y equals mx plus b, that is perfectly fine as well. Okay, so the information it gives us on this one, it doesn't necessarily give us an x and a y or an m. So the first thing that we've got to do is find those. It does tell us that we're going to be approximating this function, right, for f of 0.95 of that function, right? And we can't plug that in for whatever reason. We don't know the value. So we're going to approximate it at 1, because 1 is pretty close to 0.95. So if we can find the value at 1, that would give us a pretty good approximation. So we do have an x, or in this case, sort of our x1, right? So the other thing we need, let's go ahead and get a y. To get the y, we're just going to, we'll call the y1. We'll just plug it into our function. So f of that, that's going to be negative 3 times 1 to the 4/3 power. Well, 1 to any power is just going to be 1, so this is going to be negative 3. So that is our y1 is negative 3. Our x1 is 1. The next thing we need to get is a slope, our m. And we're finding the slope at that particular point, slope at a point. So to find the slope at a point, we need a derivative. Let's go ahead and do that. So f prime of x is going to be, we're going to use the power rule there, multiply it down. So it becomes negative 3 times 4/3 x to the 1/3 power, because we subtract 1 from 4/3 and we get 1/3. These 3's actually cancel, and it leaves us with negative 4 x to the 1/3. Or in other words, we could write this as negative 4 times the cube root of x. You can look at it in either way. Right. So then we need to find our slope at that particular point of 1. So we're going to plug it in. Our m is going to be f prime of 1. That'll give us the slope at the point. So we need negative 4 times the cube root of 1. Cube root of 1 is just 1. So negative 4 times 1 is negative 4. So there's our m. So we've got our 3 pieces of information. That's just basic algebra. Aside from the derivative computation there, the rest is basic algebra. So let's go ahead and plug it into our equation thing here. Right here. For that, we'll get y equals, our y1 is negative 3 plus our m of negative 4 times x minus x1 of 1. And just simplify this, get y equals negative 3, distribute that as minus 4x plus 4. So y equals negative 4x plus 1. So that is our tangent line equation. That's going to be our first blank. So there is a lot of work involved in this. I won't give you too many of these problems, but all right. So that's our first step. So now we can approximate f of 0.95 using this equation. So we're going to be now plugging that into our tangent line. So f of 0.95 is going to be negative 4 times 0.95 plus 1. Calculator here. Negative 4 times 0.95. And that gives us negative 3.8 plus 1. So it's negative 2.8. All right, negative 2.8. So let's go ahead and write that in. All right, now next question. So this is all we've done basically on the previous one, right? Next question says when, then we have a drop-down box. This one, it says when x is either greater than 0 or x is less than 0. So basically, we're just going to look at the x value and determine if it was greater than 0 or less than 0. Our x was 1, right? X equaled 1. So it's going to be greater than 0. So we're going to select that. And then ask us about the second derivative. So the second derivative is either greater than 0, meaning concave up, or it's less than 0, meaning concave down. Okay. So, and that's going to be the next drop-down box, which means we need to go ahead and compute the second derivative. So again, I told you there's a lot of parts to this question, but stick with it. It's going to put a lot of things together here. You can see how derivatives are really important because you use them in a lot of different applications throughout this course. So f double prime of x, if we go back up here, I'm going to use this negative 4x to the 1/3 as the easiest way to compute it there. So that would be negative 4/3 x to the negative 2/3. All right, we don't really need to rewrite it much, but we are going to need to determine if it's negative or positive. So to determine that, the easiest way to do that would be just to plug in 1 into that and see if it's positive or negative. So f double prime of 1. And again, we're just looking at the sign. Negative 4/3 times 1 to the negative 2/3. 1 to any power is still just going to be 1. So it's just negative 4/3 times 1, which is negative 4/3. So all we care about is that it is negative, which means so it's negative, it's less than 0. So that's concave down. So on that whole interval, greater than 0, it is going to be concave down, right? Because less than 0. Let's go ahead and add those in. Second derivative, f double prime of x is less than 0. So the graph is concave down. Last question, go back up to here what I said at the beginning. We said when it was concave down, it's an overestimate, right? If it was concave up, it's an underestimate. So it's concave down, which means we are overestimating. It's an over approximation. Okay, that should be it. I know there's a lot happening there. Let's see if we did it all right. Boom. All right, we did it. Okay, and you can see explanation there. There's a lot happening in this. Puts together a lot of skills from both this course and prior algebra courses. Let's go ahead and give the next one a shot. Let's clear this. All right. So first thing we need to do is get the tangent line equation. The x that we're using here looks like is negative 27. We're going to estimate negative 27.2. And here is our function. So we've got our x1. It's negative 27. We need to get a y1 and we need to get an m. So for our y1, we're just going to plug it into f. So f of negative 27 is negative negative 27 to the 4/3 power. And you could actually do this without a calculator. How you would do this is you would want to rewrite this into your rational or your root form. Remember, the top is the power and the bottom is the root. So you would do the cube root of 27 to the 4th power. The cube root of 27 is 3. 3 to the 4th power would be 3 times 3 is 9, times 3 is 27, times 3 is 81. So this would be negative 81. So very doable. You might not be able to do it that fast, but it is doable without a calculator, which is kind of the point of this, is you could theoretically do all this without a calculator. So we got our x1 or y1. Next thing we need is a derivative so we can get the slope. So f prime of x. We're just going to do the power rule there. Multiply that down, so negative 4/3 x to the 1/3. We subtract 1 from it. And then we can go ahead and get our slope by plugging our x into that derivative. So f prime of negative 27. It's going to give us our m. So negative 4/3 times negative 27 to the 1/3. Well, the 1/3 power is the same as the cube root. So the cube root of negative 27 is going to be negative 3. So negative 4/3 times negative 3. The 3's and the negatives cancel, leaves us with just 4. All of these should work out to be relatively good numbers. So if you get a bad number, it means you might have messed up. All right, now with those 3 things, we can then plug them into our y equals y1 plus m times x minus x1 formula here. So we get y equals our y1, which was negative 81, plus our m of 4 times x minus negative 27. Make sure you get the right signs there. So it's minus negative, which will become a plus, obviously. So y equals negative 81 plus 4x, and then 4 times positive 27, so it'd be 80, 28 is 108, plus 108. So y equals 4x plus, 19 and 8 would be 27. 4x plus 27. So that is our tan line equation. 4x plus 27. Okay, that's probably actually the most intensive part there, right? Once we get that, we can now go ahead and find our approximation. So we'll do f of negative 27.2. I know it is kind of confusing to have all these different f's. So if it's confusing to you, maybe even what you could do, I should maybe do this is right f tan or something. So the tangent function, negative 27.2, will then just be 4 times, we're not space here, 4 times negative 27.2 plus 27. Sorry, I kind of lost. Let me try rewriting that. Do it below it. My computer's running a little slow too. I'm recording this video at home, so. All right, so F tan of negative 27.2 equals 4 times negative 27.2 plus 27. Again, you could do that without a calculator. Probably good to just type it in to make sure you get the right answer, though. 4 times negative 27.2, negative 108.8 plus 27 equals negative 81.8. So that's going to be our approximation. Negative 81.8. All right, and now the x value on this was negative 27. So that's going to be when x is less than 0, right? That was our x value. The second derivative, so now we need to go get the second derivative. So our first derivative was up here. So f double prime of x, multiply it down. That becomes negative 4/3 times 1/3 x to the negative 2/3. And this would become negative 4/9 x to the negative 2/3. All right. Now to test this, we can plug in any number less than 0. Any number less than 0. So I'm not going to, well, actually, you could still plug in negative 27 if you want to. Maybe that'd be easiest just to always use that value. Be less confusing. Let's go ahead and do that. So f double prime of negative 27 would be negative 4/9 times negative 27 to the negative 2/3. You could also use negative 1 if you wanted to. And when we evaluate that, see, that's going to be the cube root of negative 27, which is negative 3. And then we square it. So negative 4/9. Now this is a negative, so it's actually 1 over the cube root of negative 27 squared. A lot happening there. All right. That would become negative 4/9. And then the cube root of negative 27 squared would be negative 3 squared, which would be positive 9. So that would be times 1/9, which would give us negative 4/81. The number actually doesn't matter. You don't even have to go through the whole computation, because all we're looking for is the sign, right? It's negative. So that's all we have to figure out, is whether it's negative or positive. It's less than 0. Okay. Which means the graph is concave down. Okay. So concave down, if it's like this, that means the tangent line is going to be on top. So you can always draw it there. That would be an overestimate, right? Because it's on top, overestimate. Over approximation. And cross our fingers and hope we did them all right. All right. Let's go through one more of these problems. If you are getting really stuck on this, I do want you to try a lot of them. It might take you an hour or two or more, but I do want you to try to do your best on this. Try to get all of them completed. If you're absolutely not able to do it, but you're doing all the steps right, then let me know. Take a picture of all the work that you've done and send me a picture via email with all of your work, and make some accommodations there. I know it is hard on Delta Math sometimes to get every single part correct, but all right. Let's go ahead and jump into our last one. Approximation for 4.15. Let's go ahead. We got our x1 there. So to get our y1, we need to plug it into the function. So y1 is going to be f of 4, negative 3 to the times 4 to the 5 halves. Again, this is something you can do without a calculator. It's actually good to review these rational exponent rules, because that's the same thing as, remember, top is power, bottom is the roots. So it's the square root of 4 to the 5th power. Square root of 4, of course, is 2. So negative 3 times 2 to the 5th power. 2 to the 5th is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's negative 96. That's our y1. And we also need an m. To get our m, we need to find the derivative. So we're going to do f prime of x, which is going to be negative, multiply that 5 halves, so negative 15 over 2, x to the 3 halves power, when we subtract 1. All right, and then we need to plug in our value of 4 into that to get our m. So our m is going to equal f prime of 4. So negative 15 halves times 4 to the 3 halves. Negative 15 halves. And then that's going to be the square root of 4 cubed, right? Square root 4 cubed. You are expected to know how to do that, definitely. So that would be 2 to the 3rd power, which would be 8. So negative 15 halves times 8, which would be negative 60. That is our m. So we can go ahead and write our tan line equation then by using that y equals y1 plus m times x minus x1. So our tan line equation, it's going to be y, let's say y tan, just so we're there. Y tan is going to be, our y1 is negative 96 plus m of 4 times x minus negative 60, which becomes negative 96 plus 4x plus 240. And so that's going to become 4x plus, let's see, 134, I believe. Yeah. All right, so that's our tan line equation. I'm sorry, 144. So don't want to mess that up. All right, 144. And type that in. 4x plus 144. And then we can go ahead and find our approximation. So we do, say, f tan, I'll work in there, of 4.15. Means we got to do 4 times 4.15 plus 144. So let's say we had to do this without a calculator. Now you would just do 4 times 4 is 16, and then 4 times 15 is 60. So it's 16.60 with that plus 144. And that would give us 160.6. I wouldn't advise doing this whole thing without a calculator, just because on Delta Math you mess up one part and you've ruined everything. So I would double check that using a calculator. So 160.6 would be our approximation. All right. Oh, hang on. I think I made a tragic mistake here. Let me backtrack. This negative 60 is the m, which should have gone out here. Whoopsies. Okay, so the reason that I realized that was I was checking my answer here. This is 160.6. It should be kind of similar to this y1 always. And it was way, way different. It should always be kind of similar to that. If you go back and look at the other ones, you'll see they're always similar. but I noticed that was way off from that y1. So that's why I realized I plugged it into the wrong spot. So I'm going to go back and do that really quick. Definitely do some checks as you go along, make sure everything's flowing right. Okay. Let's try that again. All right, so y1 is going to be negative 96 plus m, which is negative 60, times x minus 4. Then we get negative 96 minus 60x plus 240. And then so we get y tan is negative 60x, and then plus, so 240 minus 96. Plus 144. And we'll go ahead and plug in our 4.15. So let's say f tan of 4.15 is negative 60 times 4.15 plus 144. And that, if we did that by hand, that would be negative 240. And then 0.9, I believe. Let's go ahead and do that. I'm not going to risk it on this one. You certainly can multiply that out by hand. Negative 249. All right. And then plus 144. So I should write that out. Plus 144 equals negative 105. All right. Now, if we compare that one to negative 96, much better. It's within the same realm on that one, definitely. So that should be correct. That's why I knew that one was wrong. So definitely always double check. It's a good lesson. Double check your answers. Make sure they seem reasonable. So let's go ahead and change that to negative 105. If we can. All right. Last but not least, we need to do some second derivative stuff. This number is greater than 0, so when x is greater than 0, go ahead and calculate a second derivative. First derivative was up here, so f double prime of x is going to be negative 15 over 2 times 3/2 x to the 1/2 power, which gives us negative 45 over 4 x to the 1/2. And then we can go ahead and plug in, we can just do the 4 that we started with. It's fine. F double prime of 4. And negative 45 over 4 is 4 to the 1/2. 1/2 power is the same as the square root, so it's just negative 45 over 4 times 2. So that's negative 90 over 4, which is obviously a negative. That is concave down. It all ended up being down on this one. So if it were up, then it would be an under approximation. But this is concave down. So again, concave down if you want to draw it. Boom. Like this. Tangent line on top of it, which means the tangent line approximation is an over approximation. So the second derivative is less than 0, concave down, which means the value is an over approximation.